Yeah.
Cool. Alright. So, we have two carriers, Telstra and Optus. Telstra's offering $100 a month. It's just a straight connection fee, and then 5 cents per minute. Optus is offering $80 a month connection fee with 8 cents per minute. Cool. First of all, do we get the general gist of what's going on? No, TJ doesn't get what's going on. You're a business, so they don't give out like $40 per month plans to businesses. They give out, right, we'll charge you this much just to be connected to the network in the first place, and then we'll charge you depending on how long your calls go for. Makes sense? So straight away, they're going to have to pay $100 a month regardless of how many calls they make. And then for every minute that they're using the phone, they get charged 5 cents on top of that. That makes sense?
Yeah.
Cool. Everyone's happy? Scenario? Yeah? Cool. Okay. Great. First thing, find an expression for the cost of each carrier. Okay. So, what's going on? We're going to get a flagfall thing. So the phrase flagfall just means something that you pay regardless of what you do. So in our case, the flagfall is the $100 a month. Cool. Alright, well, I want to come up with an expression for this. We'll do Telstra then Optus, purely because that's the order they've come in. Okay, well, I'm going to need to figure out the total cost. What might be a good letter for that? I want to do it algebraically.
C.
C makes sense. Okay. Cool. Cost. Okay. What's the cost for Telstra? 100 plus something, right?
100. 100 plus 0.05x.
Right. So I get 100, regardless of what I do, I'm paying at least 100. On top of that, plus
0.05x.
Right. 0.05
X.
yx.
Because it's per minute.
Okay. Yx though.
X is the amount of minutes. Also M.
Okay, you can pick whatever you want though, right?
Yeah.
So you can pick X, that'd be fine. I'm going to suggest you pick M,
Because
because then it has meaning. It's easier if you have a little bit of meaning. I'm going to pick middle case M. Cool, cool. Great. Alright. If you want to get fancy, you can do that. Right, normally we say f of x. This is c of m. Right, so we have a cost function where m is the argument. You can just write it as c equals. You don't have to have a back and bring to show that that's optional. It's like more technically correct, but you don't need it. Cool. Is everyone happy about that? Cool. Alright. Optus.
Sorry,
Hello.
can I grab Tyler, please?
Which one? Oh, yeah.
Yeah.
Which one?
Tyler's Dean.
Steve.
Sorry.
Fine.
So I didn't realise it was two.
All good. Cool. Alright. I want to do Optus's one. Alright. Anyone want to volunteer?
What?
Go.
C
Yep.
equals 80 plus 0.08.
Cool. Fine. Again, we could put this in. Fine. So my cost is going to equal 80 plus 8 cents times the number of minutes. Cool. Perfect. Looking at those two, is there a slight problem?
Yes.
What's that?
C and M.
Say again.
C and M.
C and M.
Yeah.
I mean,
Okay,
we,
why is that?
Oh,
a problem?
J10, like.
Yep.
we don't know which one's which.
Right, which one's which? We haven't labelled anything, right? Oh, okay, well, let's rethink our system a bit then. I'll call this the cost of Telstra, this the cost of Optus. So I've got a subscript. Cool, so it's just a little thing tagged on the end just so I can tell which one it's referring to. Cool. Still a cost, it's just the cost referring to Telstra, the cost referring to Optus. We'll put Telstra usage, Optus usage. Cool. So I've got that. Great. Now for a nice annoying question. Which one's better?
You don't know.
It depends. What does it depend upon?
how much time because you spent calling.
Right, how much calls are you going to make? Right, how many calls are you going to make, or how much time you spend on the phone? Cool. Okay. So, is there a scenario, if I said we're going to make 0 calls, is one of them better? Yes, I'd also question why you're on either plan if you're going to make 0 calls, but anyway. So, if you're making very few calls, who should be better?
Optus.
Right, if you're making many calls, goes to Telstra, right. At some point, it has to flick from one to the other then. How am I going to figure out where that crossover point is? Okay.
Simultaneous.
Alright, simultaneous equations. Okay, so I've got 2 things. How many variables do I have? 2, C's and M's. Yeah? Cool, I have 2 unknowns and 2 equations. Whenever you've got that happening, odds are good you're doing simultaneous equations. Okay. Let's quickly graph both of these. Make this guy green, make this guy red. Okay. Make green. That. We've got some point of intersection in between. Cool, so this is CT, this is CO. Great. This was 80, this was 100. I'm interested in that crossover point. Let's jump down there. Cool. If you were to draw this to scale, could you figure this out on a graph?
Yeah.
Yeah, draw it perfectly to scale. Do you want to do that?
No.
No, why not?
Can't be bothered.
Can't be bothered, okay. Why can't you be bothered? Because
Very big.
right, it's time consuming, you have to draw it at the right scale. If you start at one scale and figure out crap, it's on the next page, it makes life difficult. We don't want to do things graphically, we can avoid it. So instead, we're going to try and do it algebraically.
Step 1.
Cool. Well, let's give these suckers some names. Actually, I don't even have to. Okay. How can we solve simultaneous equations? Yep.
You could use the substitution method.
Right, substitution method, okay, fine. What do you want me to write?
What you want is to what's it called? Sub equation 1 into equation 2. Or
So equation 1 into equation 2.
Oh wait, no, you want to make n the subject.
Want to make n the subject, okay.
Oh wait, no. Yeah.
Okay, how about this? When I'm here, what's equal?
Both of them.
Both of what?
Both of C and C.
Right, what does C stand for?
Telstra and Optus. Oh, cost.
Costs, right? So the costs are equal at that point, and that's the point I'm interested in. Okay, well, if the costs are equal, that means that this thing is equal to this thing. Yeah, so 100 plus 0.05 m equals 80 plus 0.08 m. Cool. Okay, can we solve this? Yes, I hope so, because we did a million of them before. Cool. Minus 80 off both sides, minus 0.05. Cool. Multiply, divide across, so 20 divided by 0.03 equals m. Which is what?
It's a big number.
Yep. Okay. I still want you to be able to do this manually. How can you, okay, first of all, can anyone do that straight away? No? Okay. What makes this difficult to do?
The point. This one.
The decimal, right? Do we have another way of writing decimals?
Fraction.
Fraction, right? Okay. So keep the 20, and we'll change the bottom. 0.03 is the same as?
3 out of 100.
3 out of 100. Right? Cool. Okay. Do we know how to divide fractions?
Yes.
Yeah. How do you divide it?
Keep changing. Flip.
Keep change flip. So you've got 20 times 100 on 3. Cool. Hold across. 2000 divided by 3. Done. Cool. If you want to change it into a decimal, what do we get? Yeah, six. Geez, what's wrong? 6, 6, 6, and 2/3. Yeah. Is that right? I think that's right. Yeah. Yep. Cool. Which of these is easier to work with?
Top one.
Top one, right? Having said that, if you just look at that, you know exactly how big it is. Maybe not. Right? So you might need to switch it to that just so that you can get your scaling roughly right. Right? But this is a much easier number to work with. So in general, we'll stick with the improper fraction. Cool. All right. Does that tell me where this point is?
No,
No. Why not?
because you need to work out the whole thing.
Right. I know the x coordinate, right, or the m coordinate. This is 2, 0, 0, 0 on 3. Cool. I still need the y coordinate. How am I going to get that?
Sub into your equation.
Right. Sub it in. Which one would you like to sub it into?
Top one.
Top one. Why?
Because it's easier.
Easier, right? I've got 8s in this, I've got 10s and 5s in that. Like that. So CP equals 100 plus 0.05 by m. Oops, wrong number. 3. Cool. Okay. So I've got 100 plus. How do you want to tackle that?
Oh, 1/2 over 1.
Half?
Oh, no.
0.05.
Yeah. 5 over 100.
Okay, so we could do 5 over 100.
Or 1 over 25.
1 over
20.
20, yeah. So we could do that, or you could go that. Either way is totally fine. Makes no difference. Alright. Incidentally, which one's going to be easier to work with?
The bottom one.
The bottom one, right? So whenever you can, generally you simplify, because it makes life easier and simpler for you. Cool, okay. So I've still got 100, 20 and 20, so I'm down to 100 on 3. We all okay with that move?
Yeah.
Yeah. Yep. Cool. Okay. Now what?
And,
Okay, how do I do that?
And then 10, so 303.
Right, convert this guy, because we need them to both be same denominator. That's 300 on 3, gives me 400 on 3. Cool. 400 on 3. Right. All of this is pretty familiar, straightforward stuff. Yeah. There's a slight tweak that I want to make, which is that should be in dollars, that should be in minutes. Cool. Just like always relate it back to whatever you're actually talking about. Beautiful. So that's whatever it is, 2G. It's going to be that sort of stuff, just taking expressions, turning them into equations, figuring out specific parts of the equations. Pretty straightforward, you've done that a million times. 2H is simultaneous equation stuff. So, yeah. Well, actually, I'll give you, okay. Does everyone know how to tackle these?
Yeah.
Everyone know what they want to do?
I forget.
You forget? Cool, one's out. Cool. If you already know what you're going to do, have a go at it now. Cool. Forget. You're okay. Forget. Things on, forget. On, forget. Oh, okay, so 1, 2, 3, 4. Okay. I've got 2 equations. For simplicity, you can call these guys equation 1 and equation 2. You can call them A and B. Any smiley face, granny face, they're just symbols, labels, things. Okay. Well, I want to get rid of either X or Y. Well, 3s and 5s don't really go together too well. 2s and 4s They do play better together. Okay. Well, if I take equation 1 and multiply it by 2, I would get 4 x's, 3 y's, and 8. We're okay with that? So this whole thing multiplied by the number 2, not equation 2, the number 2. Right? I get twice that, twice that, twice that. Cool. We're happy? Yep. Cool. Well, now I've got these things lining up. So we go, cool, I'll call this something new, I'll call it equation 3. Okay, I can take equation 3 and take away equation 2. This minus that, 0. Right, dead. 6y minus 5y, y, 8 minus 6, 2. Cool, y is 2, beautiful. Great. Well, I figured out what y is, still need to know what x is. Okay, so I'm going to sub this back into either of my 2 equations. Since I can use either of them, I'll use the easier one, which would be the top one in this case, numbers so on. Cool, so we've got 2x plus 3, 2's equals 4. Cool, and now we're just solving basic stuff again. Yeah. 2x equals -2, x equals -1. Cool, we're happy about that. Cool, everyone got -1, 2? Yep, everyone's happy, beautiful. Cool. One small thing, commonly, you'll see answers written like that, as though it's points on the xy plane, because they could be. It's just a different way of writing it. I don't particularly mind if you do this, or that, unless it specifically asks what are the coordinates of intersection. Then it has to be in the green way. Yep.
How do you get x equals -1? I got x equals 5.
Okay, so I've got, did that line, you got y equals 2?
Yeah.
Yep, okay. That was your next line?
Yeah.
Cool, okay. I've got 6 there. I'm minusing 6 to the other side.
Oh, yeah, I plus.
You play. Yeah, cool. Alright. Cool, alright. Aside from the fact that most people have got it, how could we be confident that this was true? Right, sub it back in. We already used this to generate this, so we should sub it into the other one. So this is now a check with point 2. Okay. What have we got? 4 lots of -1 plus 5 lots of 2 equals 6 question mark. Cool. -4 plus 10 equals 6. Yeah, that works. Never confident. Yep.
How would you do that if you substitute?
How would you do that if you substituted it? As in, if you use substitution instead of elimination?
Yeah.
You can do. I'll do one over here that'll give a bit of exactly that question. Okay. For this one, elimination is overwhelmingly faster and easier.
You don't have to rearrange it.
Right, exactly. Right. So let's go. One of those.
So I did an elimination and substitution, but my substitution was wrong.
Okay, I'll look at that specific thing in a second then.
No, it's transparent strong.
Yeah, I probably do. Did you push record?
You can read. Yes. Yep. Is anyone totally happy to kill that by themselves? Yes? If you're happy to kill it by yourself, go now. See how you go. I don't think you'll end up with nice numbers on this one. Is anyone dead before they started? Yep. 1, 2. Fletcher's, you're okay? Fletcher's okay. You're okay? Cocaine okay? Okay. Fair enough. Cool. So we're looking at this. Okay. Well, it looks on the first of it that we could eliminate these two. And you could. There's a mild problem though. This one's got y's on the left, this one's got y's on the right. So they're not lining up nicely like this one did. So this one you've got options. Right? You could do one of two things, but I would suggest that you notice something else instead. Those two things are the same. Yeah? So, false equation 1, false equation 2. What I can do is replace this guy with this guy. because 2x is this, so I can just replace the 2x with this. So I can take 2 into 1. So now I've got
5y minus 6 plus 3y.
5y minus 6. Oops. So that's this purple bit. Actually, I'll put that in purple brackets just to make it clear. What's going on? Equals.
Yeah.
No, not equals. So I've got that bit plus 3y equals 4. Cool. Great. I've only got one variable in there, so now I can solve it. Cool. So simplifying that, I've got 8y minus 6 equals 4. So 8y equals 10. Y equals 514 when you simplify down. Cool. Let's go done. Great. And now we're back into the same thing. You're just going to sub it into either of them. In this case, which one would you prefer to sub it into?
Bottom one.
Bottom one? Okay, why the bottom one?
Nah, I'll just go top two.
It's up to you, you can go either. I would actually go the bottom one in this case. For one reason and one reason only. Are either of these obviously better? Top one's got slightly smaller numbers. Okay. What are you trying to solve for?
What?
X.
Oh.
Which one's already got the X isolated?
Two.
Bottom one. So that's why I picked that. Having said that, you can do either. It won't matter. You'll so long as you don't stuff it up, you'll eventually end up at the same point. I'm going to actually stuff it into the second one in this case though. I've got my 2x equals 5 lots of 5 on 4 minus 6. Cool. 2x equals 25 on 4 minus 6 is the same as 25 on 4. Sorry, 24 on 4. So I've got 2x equals a quarter. Divide by 2. X is 1. Cool. Anyone get to those on the autopilot by themselves? Yes? Some yes, yes? Cool. Good job. If you're doing that automatically, this is going to be nice and easy for you. Cool. Cool. Yes, fine. Brilliant. Okay. Last one. Move that. Good? No, I don't even want to do that. Let's go. Is that good? Yes, that's sufficiently annoying. Okay, so now I've got this guy. Is there an obvious mode?
No.
Minus 5x.
So no one's happy within the first 10 seconds of looking at the, I know exactly.
Oh, yo.
There's a couple of options that you got, so. Solve 2 for x? What does that mean? Solve for 2x? Is that what you're saying?
solve for x in the second equation.
Solve for x in the second equation? Oh, I've got multiple x's. What am I doing? Sorry. No wonder everyone's confused.
Oh, certainly. You pulled my arm, man.
So, change one thing and confuse myself in the process. Good job. Sorry about that. Okay. Sorry, okay. Give you another 10 seconds to look at that. Is there anything immediately obvious come to mind?
3 times both of them until you find a factor.
Okay, so you've got that. Beautiful. Is there a one-shot thing that's going to solve this?
No.
No, they're sufficiently irritating that you're going to need to do at least 2 things. Cool? Yeah, okay. You have options though. If you prefer substitution, you can fiddle with it and then do substitution. If you prefer elimination, you can fiddle with it and then do elimination. Totally up to you. Alright, it's methods with an S, there's more than one way to get there. Is everyone happy that they can attempt this though? Yeah? Cool. I won't touch it then, I'll give you a minute to knock it out. Ready, set, go.
15 plus 16. 30. 31. Done.
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 People getting stuck on fractions, or is that what's happening? Yeah, no, maybe, I don't know. Give it another 30 seconds. Quick show of hands. How many people tried to do some kind of substitution? How many tried to do elimination? Okay, maybe 1 to 2. Okay. You can totally go with either. I'm going to do the following. I'm going to change equation 2. We go 5x minus 8y equals -7, just so that everything lines up. Cool. And then I'm going to do what? Okay, I'll take equation 1, multiply it by 5, take equation 2, multiply it by 2. This is just one way, there's multiple ways of doing it. So 10x plus 15y equals 20, plus 2 is 10x minus 16y equals 14. Cool, call this equation 3, this equation 4. We'll do 3 minus 4 rather. Kill each other. This minus this becomes 31y. This minus this becomes 34. Y equals 34 on 31. Yuck. It's a number. And
Go!
you happy with that? Okay.
Gee, I thought I was pulling numbers out of my ass, to be honest.
So we've got 2x plus 3 lots of 34 on 31 equals 4. I can see why people were fiddling around a bit for a while. Oh, okay, so we got 2x plus, what's this, 2, 1, 102 over 31 equals, this is going to need to be out of 31, 124.
Simplifies to negative 4 to 31.
2x equals minus that gives me 22 on 31, divided by 2 equals 11 on 31.
Damn it!
Not so happy with the second one?
I times it, didn't divide it.
I'm not so happy with that, no.
Yeah, I got negative 4 over 31.
Okay, how many people got one of the two of them? Okay, yeah, cool. So that's nice. Cool. How many people, if let me work back. Okay, hang on. Did anyone get perfect? 1, 2, good job. That's about as annoying as they'll get.
I know
Right, just annoying numbers.
where I stuffed up.
Inherently, is any one part of that difficult? No, right? Each step to step isn't overly difficult. It's just because you've got a lot of little things happening, right? And because you're human, a lot of little things usually means something's going to get dropped. So you just have to be super careful with the way. Okay, let's... Oh, by the way, is anyone 100% confident that that's right? Okay, Riley, have you already checked it? Or okay, you've already checked it, so good. Right, just on the face of it, is it obvious that that's right? Not even slightly.
Yes.
Hang on, didn't you just get it wrong?
I know that's right, because I got mine wrong.
Bad one. I still make errors. Okay, so we use equation 1 to generate it, so we should use equation 2. So 5 lots of 11 on 31 equals 8 lots of 34 on 31 minus 7. Cool, turn everything out of 31. 55, yuck, and going. Let's change it on green. 55 on 31, 31. What's this? 2, 3, 24, 272. Times by this is 217. Okay. 272 minus 217 is 55, yeah?
I don't know.
Yep. Cool. Yeah, cool. So that checks out, so we're good. Only by checking that am I confident that that's right. Just by looking at this, I have no idea if that's right or not. Okay, so you're in human company. Is everyone happy with these first two? Yeah? Cool. Is everyone, other than the irritating fractions, are you happy with the third one? Yes. Is it just the irritating fractions that are... Yep. Okay. Guess how you get good at that?
Practice.
You practice it, right? You smash your head against the wall until eventually either your head caves in or the wall caves in. Right? You just get better at it with practice. Cool. Last one. Is this of the same type as the other three? Why not?
There's 3 variables.
Right. There's a third variable in there. Cool. The m. How many equations do I have? How many variables do I have?
3.
Okay. How many solutions does this thing have? Okay. If I give you the equation y equals 2x plus 4, how many solutions does that have? Infinitely many.
Oh, yeah.
Because it's the entire line. Anywhere on that line satisfies that. Right? So if I've got one equation and 2 variables, I have infinite solutions. I have this. How many solutions does this at least potentially have? Infinitely many. Because I've got more variables than I have equations to restrict them. Cool? Alright. Well, here's what we want to do. We want to solve this. Now, that doesn't really make sense because if we solve it, there should be infinitely many solutions. But we're going to say, okay, let's see if we can find any solutions for it. So, we're going to do like we did before. Equation 1, equation 2. What would you like to do?
Divide them all by 2.
Divide the second one by 2, yeah, or multiply the first one by 2, either either. Yep, okay, we can do that. Second one divided by 2. We get 2x plus 3y equals 4. Okay, what do you want to do from there? Call this equation, right?
Oh. Eliminate.
Ah.
Eliminate. Okay, so we'll go equation 3 minus equation 1.
Elimination.
2x minus 2x, gone. 3y minus my, so I've got 3 minus m, lots of y, equals 4 minus 4, 0. Okay. I want to solve for y. What do I do?
What? Oh.
Divide by.
Divide by this, right?
Divide by.
Okay. Well, if I divide by that, I get that. That seems weird, doesn't it?
Does it?
Okay, well, let's find out.
I don't think so.
So, what do I do from there?
Sub it in.
Which one would I sub it into?
1.
You know about that?
Yeah, nah, I get.
Maybe 2, right? Because that's all numbers.
Yeah.
Yeah? Okay, we'll sub it into 2, so we get 4x plus 6 lots of 0 equals 8. Therefore, x equals 2.
Oh, and then sub that into your equation.
So I've got 2, 0 as my solution.
1. And then sub it
Okay.
into 1.
Does that seem odd?
Yes.
Yeah, because we said before, this thing should have infinitely many solutions, so what's going on? Well, let's sub it in and see what happens. So I get 2 lots of 2 plus m lots of y equals 4. Does that work?
No.
Yeah. What's m times 0?
No. 0.
0. 2 times 2 equals 4.
But then you can't figure out what M is.
It works. So this is a bit weird, right? And this is what throwing extra variables in can do. Well, let's consider something else.
I think M is equal to 3.
Right, what happens if m is equal to 3? So, you know, that's what we've got to do there. If m equals 3, taking a look at, where am I going?
We probably say where we got 3 from.
That one with that one. If m equals 3, what happens?
The equation becomes the same.
They become the same equation. When does a line intersect with itself? Always, everywhere. Everywhere the lines exist, they intersect with themselves. Yeah? So that's where our infinite solution is. Infinitely many solutions. Right, okay. Well, the point 02 was one particular solution on that line. The trick to this, we stuffed up when we did this bit. So this line's okay, this line's not. What happens if m is 3?
0.
I get 0y equals 0. Okay, I've then divided by 3 minus m, but we just said that that was 0. Can you divide by 0? No, so this is divide by 0 error. That's why we got a solution even though we shouldn't have got one solution. So you have to be super careful when you're dividing by expressions. Right, if the expression can't equal 0, fine, go nuts, you can divide by it. But as soon as it can equal 0, you have to be super careful. So at this point, this is true if m does not equal 3. That's the only solution you're ever going to find. However, if m does equal 3, you've got infinitely many solutions. Okay? So it gets a wee bit tricksy when you start adding in extra things. Cool, let's go something else. 3x minus 4y equals 5. And go... What are the x this time? mx plus 8y equals... Actually, let's make that 12, just so it's like a bit better. Cool, 3x minus 5, 3x minus 4y equals 5, and mx plus 8y equals 12. Okay. Before we even get started, what are we expecting to have happen?
Multiply the top by 2.
Say again?
Multiply the top by 2.
Multiply the top. Actually, I'm going to change something.
Well then,
I'm
don't
going to
multiply
totally
by 2.
change the whole thing.
Okay.
No, wait, I'll do that on a separate
Okay.
example again. Sorry.
Alright.
Because there's 3 separate things. Cool, okay. Okay, sorry, so what are you expecting to have happen? The same thing as last time, which was...
It was in there.
Okay, so we're conscious of dividing by 0, might be a problem. What end result are we expecting? some kind of infinite solution thing should turn up somewhere. Right? Because we've got 3 variables and only 2 equations. Okay. Cool. Alright, how are we going to solve this thing? Question 1, question 2. Times 1 by 2, alright? Because that will give us
6.
Let's say y equals 10. Why is that useful? Right, the 8th one up. Right, or the y's one up, I should say. Cool. Next move. Add them together, right? Because I've got a positive 8 and a negative 8. So call this equation 3. Equation 2 plus equation 3. 6 and m, so 6 and m, lots of x. These two cancel each other. These two add 22. Cool. Okay. Next move.
Oh, wait, never mind. Divide them by 22. Divide them by 6 plus 8.
Okay. So divide by 6 plus m. Is anyone going to say anything at this point? Say again. M is a variable, so we should think. Is there something that's going to stuff up that move? As in, what's 0?
Sub that into the equation.
Right, if m is negative 6, this thing becomes 0, and we just divided by that. So this is only true if m is not negative 6. Right, because 6 minus 6 would be 0. 22 divided by 0, undefined, we're broken math. Right, which is usually a bad idea. Sometimes it's interesting things, but usually it's a bad idea. Okay. Well, that's that. Do I even have a solution now?
Yes.
Do I? I don't know. I've got x in terms of m.
You've got an equation.
Right, I've got an expression for x in terms of m. Okay. Well, can I simplify that any further?
No.
No. Alright. That's my solution.
No.
That's one of my solutions for x. Okay. If this was a number, what would I do next?
Substitute into
Sub in. Which one would you like to sub into?
2.
Probably 1, TJ, because 1 doesn't have m's in it.
Oh.
Yeah? It's an easy one to deal with.
No.
Cool, so I've got 3 lots of this thing minus 4 lots of y equals 5. Can I isolate that y? Yeah. So let's isolate. So I've got negative 4y equals 5 minus, I'm going to change it to 66 on 6 plus m. Divide by negative 4. So I've got 5 minus 66 on 6 plus m over negative 4, which I can move stuff around, make that positive, positive, get rid of that. Alright. Actually, hang on, let's do one thing at a time so that actually makes sense of your notes. Cool. This will leave as, which one do we want to leave as? Negative 5 on 4 plus. Divide that by 4, is that going to go? No, of course not. So we'll get 33 on 12 plus 2. I'm not overly worried if you're going from there to there and you get lost. I would encourage you to try to figure out how to get from there to there. But it doesn't really matter right now. Yep. Okay, so that's why. Is this a nice, easy solution?
No.
No. It's an algebraic one, no. Cool. Does this have limits on what m can be?
Yes.
Yeah. So for this, m can't be negative 6. What about this?
Can't be 6.
Try again. Negative 6, yeah? Yeah? Because 12 plus 2 lots of negative 6 would also be 0. So it's got the same constraint. M can't be negative 6. Okay. Is there a question that seems needing of answering?
What is m?
What is m? Okay. M is whatever you want it to be. M can be anything except negative 6, then these will be correct. So these are correct so long as m is not negative 6. It doesn't matter what m is.
What if m is 0?
What if m is 0? Okay, so m is 0, so x is 22 on 6, and this is whatever that is.
Well, what happens if m is negative 6?
Thank you, that's the question I wanted. Okay. So, Okay, so we've answered if m is anything except for negative 6, but what if m is negative 6? Is it obvious what's going to happen? No. Okay, so we should probably write the equations and sub in them. So we've got 3x minus 4y equals 5, and negative 6x plus 8 equals 12. Does anyone see it straight away? Yeah? What's happening?
We're going to get a thing that doesn't work properly because...
Cool. It ends up with no solutions. Cool, okay. We can try to make this work. Equation 1, equation 2, times equation 1 by 2.